All right, welcome to another example on sampling distributions and standard error. So this example, for the population of Walmart workers, suppose the weekly income has a distribution that's skewed right with a mean of $500, and it has a standard deviation of 160. Now keep in mind that the standard deviation that's told to us here is the standard deviation of the population. And then we take a survey of 100 workers. So question one, what's the mean and the standard error of the sampling distribution? So again, quick recap on what a sampling distribution is. So if you were to take 100 workers and take their average salary or their mean salary for the week, and you were to continue to do that, no, let's not do it. What are the mean and standard error of the sampling distribution? Let's go over what sampling distribution means again. So let's say you take 100 workers and you take their mean salary. And then you go and take another sample of 100 workers and you find their mean salary. And you were to continue to do that over and over and over again, keep taking these samples of 100 workers and finding their weekly income. That would create a frequency distribution of weekly incomes. This is called a sampling distribution. It's a sample distribution or a frequency distribution of all these means of samples. Now we have two properties that allow us to answer question one. The first one is that the mean of the sampling distribution is exactly the mean of the population, and that is $500. And then we have a formula for the standard error. Now, again, the standard error is the standard deviation of this sampling distribution that we took, or in theory take. Now, the notation is that, and it's going to equal the standard deviation of the population divided by the square root of the sample size. And so that's $160 divided by the square root of 100. That's exactly 16. So again, that frequency distribution of all the mean weekly incomes, the standard deviation of that is about $16. All right, question two. What is the probability that the mean weekly income of these 100 workers is less than $448? So the notation would look like this. We want the mean going to be less than $448. Now what I want to do is convert that to a z-value so that I can look it up in a normal table. So let's convert that using this formula, z equals x bar minus mu over, and then on the bottom it's the standard deviation, but because we're talking about the sampling distribution, we have to use the standard error on the bottom. And that is going to be 448 minus 500 over 16. That's negative 3.25. So now we can rewrite it. Instead of saying x bar is less than 448, we can say z is less than negative 3.25. And when you look it up in the table, a z-value of negative 3.25 is 0.0006. So what does that mean? It means that it is extremely unlikely for us to take a sample of 100 Walmart workers and get a mean weekly income of less than $448. Again, 0.0006, meaning it is extremely unlikely for that to happen. Now we can calculate this on a graphing calculator. So that's using the normal CDF. Now you can type that in using the original information where you have a mean of 500 and a standard deviation of 16, or you can do it with the z-values. Now we have the negative 10,000 in both of these places because in the normal curve, you're always going from left to right. So if you want to be less than 448, then your left bound is basically negative infinity, but you can't type that into the graphing calculator. So you just use a very large negative number. And you can see in both of these, it is in scientific notation, but when rounded, that is 0.0006. All right, let's move on to part 3. What is the probability that the mean weekly income of these 100 workers is between 480 and 520? So in this one, I'm actually going to draw the normal curve, just to get a visual on what's happening here. Now, because the mean is 500, 480 is going to be to the left, and 520 is going to be to the right. And we are looking for the area between these two. Now, writing it out, our notation would be the probability 480 less than x bar less than 520. But I want to convert both of these to z-values. So again, the formula I'll put over here is x bar minus mu over the standard error. So this would be 480 minus 500 over the square root, sorry, not over the square root, just over 16. And that's negative 1.25. And then for the 520, we get 520 minus 500 over 16. And that's a positive 1.25. So we can write this now with z-values. Say negative 1.25 less than z less than positive 1.25. Now we have a formula that lets us calculate this. So what you're going to do is you're going to take the probability of being less than 1.25, so always take the right bound, and then minus the probability that you're less than the left bound. So now let's look up both of these z-values. So for 1.25, we get 0.8944. And then for negative 1.25, we get 0.1056. And that equals 0.7888. Now, if you go ahead and use the graphing calculator, you're going to do the normal CDF. You're going to have your left bound and your right bound, so that's negative 1.25 and positive 1.25. You have a mean, because again, these are z-values. The mean is 0, standard deviation is 1, and you calculate it and you get 0.7887. Again, rounding is the reason we are off a little bit. But you can also use the normal CDF with the original information of 480 and 520, the mean of 500 and a standard deviation of 16. So what does this mean? Well, there's about a 78-79% chance that you take a sample of 100 Walmart workers, you find their weekly income, again, 78-79% chance that it is going to be between $480 and $520.